Welcome to this overview of side-side angle. We are going to show why side-side angle does not work to prove triangles congruent and why it does not generate a single triangle fitting the criteria. Now first, side-side angle means that we have two sides with the angle that is not in between them. So when we go to draw this, we're going to start with a side. It could be this side here on the bottom. For consistency with the other videos, we will call that line segment AB, and we will write that we draw line segment AB. Now let's go to the angle. So over at point B, we would have an angle coming in here. We don't know exactly what its size is, and we do not want to refer to specific numbers on the test. We're just showing how this construction unfolds. So I'm going to put it somewhere like this, make it into a ray, and we're going to say that C must be on this ray because of the measure of angle B. Then we've got the other side stemming from point A. And what we're going to do is we're going to take our compass and we're going to make a circle from point A. And we will indicate that C must be on this circle because of the distance from A to C. Now we have two options for point C. One up there that I'll call C1, one over here that we'll call C2, and then we're going to draw in those two triangles. Now what we would need to see on the test is we would need to see you draw out those two triangles separately. They do not have to be perfect, just draw them kind of sort of how they look. Does not have to be perfect. You're not having to draw them 100% to scale. But draw them out and label them C1AB and C2AB. And then note them accordingly. Segment AB is the same on both because we started with it and that was one of the sides provided. Angle B is the same on both because that's how we drew this thing in. That's the angle that we were provided. And then based on the circle, AC1 and AC2 are both radius segments. So those two sides have to be congruent. And now looking at these triangles, they have the same side, angle combination, but they are clearly different. They are not congruent. So you would say triangle ABC1 is not congruent to triangle ABC2. Clearly we can see why that's the case. So the answer to this question, how many completely different triangles can be formed given side-side angle? It could be two, and as we discussed in class, it could be one or it could even be none. But the key problem is that there could be two triangles. So this would not work to justify that triangles are congruent. This is what I would need to see on the test as explanation. And really quickly, out of curiosity, if you're wondering, well, how do you get one triangle? Well, you would get one triangle if, when you set the sides of your compass, it just kind of bounces off. Over here, there would be one point for C. And if you're asking, well, how would you get no triangles? Well, if you spin it around like this, that circle would never cross the opposite side. So you could get two, one, or none, but what really matters is right here where you get two triangles, because that shows us that we cannot trust side-side angle in order to guarantee that triangles are congruent.